In the last video, we focused on the 45, 45, 90-degree triangle. We're talking about special right triangles. So we're looking at the 45, 45, 90. That's the one we did last video. This video, we're going to focus on the 30-degree, 60-degree, 90-degree triangle. But let's review what we did last time. For this first model here, 45, 45, obviously this is an isosceles triangle, so the legs of this triangle are the same length. So if this has a length of x, this has a length of x. And I showed you how to derive this model that I'm going to look at right now. So let's look at the two models that we look at. So we have a right triangle here, and the legs of the triangle are the same length. We're going to call them x and x. And it turns out that using the Pythagorean theorem, if this is x and this is x, the length of the hypotenuse will always be the square root of 2 times the length of either of the legs. They're the same length. So this means that if you're given a triangle and they tell you that this length here, this side here is 3 units, whatever, inches, feet, whatever, and this is all has to be 3, because if it's 45, 45, the legs have to be equal, the length, isosceles triangle. So the hypotenuse has to be the square root of 2 times either one of the legs. They're the same. Now you can use, I went over some problems, and I mentioned again that you can use the Pythagorean theorem. In this particular case, you have the leg and the leg over here and the hypotenuse. As long as you're given 2 of the 3 lengths there, you can use the Pythagorean theorem. But it's very easy to solve some of these problems just by using this fact here. So if I say this is 8, this side is 8, what are the lengths of the sides? Well, let's call this x. This has to be x then. So how do we get the 8? Based on what we just said, and what we said in the last video, the length of the hypotenuse will always be the length of one leg times the square root of 2. So solve for x, divide by the square root of 2. This divides out. So x is equal to 8 divided by the square root of 2. You have some problems involving radicals. Make sure you simplify. So here we can eliminate the radical from the denominator by multiplying the denominator by the square root of 2. But if we do that, we have to multiply the numerator. And that's legal, because all I'm doing is multiplying by the square root of 2 over the square root of 2. That's 1. 1 times any number doesn't change it. So this gives me then radical 2 times radical 2 is the square root of 4. Square root of 4 is 2. So 8 divided by 2 is 4. So the length of the leg, that's x in this case, is 4 times the square root of 2. And that's all you have to do with this type. Now with the other one, the 60-30, again, this is, I don't have to do this now. I could, with this notation here, a symbol here to tell you that's 90 degrees, but if this is 60 and this is 30, the third angle has to be 90 degrees. To the two models, these are the ones you have to really know, either memorize them or learn how to derive these. In the last video, I derived the one for the 45-45. Now let me show you for the 30-60. I'm going to do this. Let's say that this is 2x, this is 2x, and this is 2x. Then I'm going to drop a perpendicular from this vertex here to the other side. So this is a right angle. Now what happens here, since this is in a what I created here or drawn is a equilateral triangle. All the sides are the same length, 2x, 2x, and 2x. So that means that all the angles have to have the same measure. So these are all 60 degrees. This is 60 degrees. This is 60 degrees. And this angle here is 60 degrees, but when I drop this perpendicular, it bisects it. So this gives me 30 degrees. So I'm going to take half the triangle here. Now this perpendicular also divides the opposite side. So this length here is 2x. So this then is x, and this is x. So what I want to know is, what is this side? I'm just going to call it y. So this side right there. So this is why I'm going to use the Pythagorean theorem. You have a triangle, the sum of the squares of the two legs has to equal to the square of the hypotenuse. So this means that y squared plus 2x, I'm sorry, this has to be 1. This is 1. Because I'm looking at this triangle, the smaller one here. The perpendicular divides the big triangle into two right triangles. So this is x, so this is y squared plus x squared is equal to the square of the hypotenuse. In this case, the hypotenuse is 2x. I square that, it gives me 4x squared. Subtract x squared from both sides, I get y squared is equal to, subtract x squared here, and x squared from 4x squared is at 3 x squared. I take the square root of both sides, only the positive root, because I'm dealing with length, so I can't have a negative length. So I take the square root of this side, square root of y squared is y, and then the square root of 3, or 3x squared, I can do this. Since x squared is a perfect square, the square root of x squared is x. So I get this triangle right here. So this tells me that the side opposite the 30 degrees is x, right there. The side opposite the 60 degrees is y, which is square root of 3, x. And of course the hypotenuse is 2x. Okay, so that's how I derived, or you can derive these formulas. Well, not these, but this one right here. Okay, so we did the 45-45 last time, and I reviewed it right now. So here's what you have to remember for this one. You can construct it by saying, okay, the length of the side opposite of 30 degrees is always going to be x. So we want to know this. If it's not given, we can find it depending on what's over here on this side. So notice that the length of the side opposite the 60 degrees, which is this right here, is whatever this is, multiplied by the square root of 3. Okay, so if you know this side opposite the 30 degrees, the length of the side opposite the 60 degrees is the square root of 3 times this value. Now, if you know this value here, you also know this one, because this one is twice that one, and that's the way it works. So you're saying, well, what happens if we know this one? How do we get this? Well, going from here to here, what do? Divide by 2. And we get this one. Or if you're given this one, the side opposite of 60 degrees, how do we go? How do we get x? Well, divide by the square root of 3, and you get the x. You get this one then by multiplying this one by 2. So also know that the longest side is always opposite the largest angle. Well, in this type of triangle, the largest angle is 90 degrees. So 2x is the longest side. Or the smallest side, I should say, is opposite the 30 degrees. And then the middle side's length is the side opposite the 60 degrees. It's the square root of 3 of this side, x. So 2x is the longest side, the smallest side is x, and then the middle side's length is x times the square root of 3. But you need to know these two models right here. Sometimes you're going to work a problem that involves both of them. Got some problems here. Let's look at this one right here first. Find the value of x. Find the value of x. It's a 60-30 triangle. As we saw, 7. This is the middle length, and x is the smallest. So the length of the side opposite the 60 degrees, and let me do it this way. The length opposite the 60 degrees, if you look at your model, it's always the square root of 3 times the side opposite the 30 degrees. That's x. So then we solve this for x, so divide both sides by the square root of 3. This cancels out. So x will equal to 7. Now all we have to do here is rationalize the denominator, that is, eliminate the radical from the denominator. We can do that by multiplying by the square root of 3 here and also on top. Remember, here we're just multiplying by 1 because the square root of 3 over the square root of 3 is 1. 1 times anything gives you the same number back. So then you say, okay, x then is going to equal to 7 times the square root of 3. And radical 3 times radical 3, that's radical 9. Square root of 9 is 3. So the answer to this one comes out to be 7 times the square root of 3 over 3. Do this. Now let's suppose we had this problem. Suppose you want to find the value of x, and let me just make this x and y. So let's say this is y here. So forget about that x. This is y here. And this is x. And let's say instead of this 7 here, this is 4. Times the square root of 2. Let's try to find y first. So the side opposite the 60 degrees is 4 square root of 2. And remember, that's always equal to the square root of 3 times the side opposite the 30 degrees, which is y. So this should equal to y times the square root of 3. Again, the side opposite the 60 degree angle is always equal to the square root of 3 times the side opposite the 30 degree. So all we got to do here is solve for y. So divide here by the square root of 3. Square root of 3. This cancels. So y then is equal to 4 times the square root of 2 over the square root of 3. And that's really the answer, except it's not simplified. Your instructor's going to want you to rationalize the denominator, so again multiply here by the square root of 3 to make that a perfect square in the radicand. So this is equal to then 4. And then radical 2 times radical 3. Since they're both square roots, we just multiply the radicands. 2 times 3, that's just 6. And then down in the denominator, the square root of 3 times the square root of 3. This is the square root of 9, which is 3. So the value of y is 4 times the square root of 6 over 3. Now remember, the hypotenuse for this model, this x, is always equal to twice the length of the side opposite of 30 degrees. We just found that to be y. So x is equal to 2 times 4 times the square root of 6 over 3. So here you can just multiply the 2 and the 4. Don't want to multiply the 6 because that's under the radical. It's just 2 times 4 is 8. Square root of 6 over 3. That's the solution to that one. clear this then. And let's look at this one here. And sometimes you're going to have problems like this where you might have to use both models. So here you can see there's two triangles kind of put together here. You can see this angle here is 90 degrees. Gives you the notation for 90 degrees. And then this angle here is W degrees. This angle here is W degrees. So you should know that this is your 45-45 model. Because if this is 90 degrees, these two have to add up to 90 degrees. Because the total number of degrees in a triangle is 180. So these have to add up to 90 degrees, and they have to have the same value. It's W degrees, it has to be 45 and 45. So now we can do this now. What do we want to find? We want to find x here. So this is 45-45. We know one leg. So we know that the hypotenuse is always the length of any of the legs, which of course this is 5, this has to be 5. It's not given, but you should know that this is also 5. So this is just going to be 5 times the square root of 2. Now we can deal with the other triangle. And notice to tell you that this angle is twice W. But based on what we just said, W has to be 45, so that tells me that this is a 90 degree. That's 90 degrees. 45 times 2. So that angle right there is 90 degrees. So let's write this triangle over here then. This is 5 square root of 2. This is x. This is 60 degrees over here, so this has to be 30. This is 60. And this, of course, is 90 degrees. So let's call this y for now. We have a 30-60 degree triangle, and the length of the side opposite the 60 degree angle is 5 radical 2. Know from what we just said earlier, the side opposite the 60 degrees, in this case 5 radical 2, is always equal to the length opposite the 30 degrees. In this case, we're going to call it y, times the square root of 3. So now we just solve for y. So divide both sides by the square root of 3. This cancels out. And then over here again, we're going to multiply by the square root of 3 and the square root of 3. So the square root of 3 times radical 2, this will give me 5. Square root of 6. Again, we're multiplying this by the square root of 3 to rationalize square root of 3. Radical 3 times radical 2 is radical 6. And then the square root of 3 times the square root of 3 is square root of 9. Square root of 9 is 3. So this side, and notice it's asking for x, but sometimes you have to find some more additional information to get to this point here. So now, we noticed when we went over the model that the length of the hypotenuse, and that's what we're looking for, in this case x, is always equal to twice, or 2 times, the length of the side opposite the 30 degrees. We just found it, it's y. So this is going to equal to 2 go to 6 over 3. 2 times the square root of 6 over 3. And then we just multiply that by 2. Again, the 2 doesn't multiply the 6, so that's under the radical. You can multiply the coefficient. 2 times 2, that's 4. Radical 6. And there's a mistake on this one. This is 5, not 2. So this is 5 right here. That's the length of y. So the length of the hypotenuse is twice the length of the side opposite of 30 degrees. So now 2 times 5 is 10. Square root of 6. It's over 3. Now this is your exact answer. They might ask you to give an approximation. Sometimes they give the value of x to 1 decimal point or 2 decimal points. So you can go ahead and use your calculator, and if you do this, you calculate this out, you get 8.16 to 2 places. A lot of times they're going to ask you to give the exact answer. So again, keep in mind that these types of problems, sometimes you'll be dealing strictly with a 45, 90 degree model. Some cases strictly with a 30, 60, 90 degree model. In some problems they can combine both of them. And also keep in mind that in some problems, like ones that I did earlier in the last video, you can use the Pythagorean theorem. If you're dealing with a right triangle and you know 2 other sides, and you're looking for the 3rd side, this Pythagorean theorem tells you that the sum of the squares of the legs is equal to the square of the hypotenuse, or the square of the hypotenuse is equal to the sum of the squares of the other 2 sides, or the legs. Thanks for watching. We'll see you next time.